geometry students, we're back to section 1.3 or 1.1. We're doing example 3, and we're going to start introducing. I'm going to introduce to you some concepts called postulates. You're going to see so many of these for the next months that we're together. It's not even going to be funny. So another name for postulate is the word axiom. You're going to hear me call them postulates more often than not. I probably won't ever call it an axiom ever again. But if you ever hear this in conversation with someone and someone's talking about an axiom, this is what it means. It's a statement that's accepted as true without proof. Okay, a proof is, did you see it, hear it, did you use your senses to detect it? And so a lot of times in geometry, especially in this early stuff, we don't actually see it. We can't see a point. There's no definitive size to it. So it could be there where we could actually see it, and it's understood or inferred to be there if we can't see it. Okay, same thing with lines, because lines don't have thickness. Just because you can't see a line doesn't mean there isn't one there, okay, connecting 2 points. So we're going to make up some postulates, and I'm going to give you some options here. Let me box this in right here, because throughout the year I want you to keep up with postulates and other things that we're going to be learning. What I'd like you to do is create one of two things. I don't really want you to do both necessarily unless you think it will benefit you. A couple years ago when I taught this class, my girls, I had 4 girls in the class a couple years ago in geometry, and they did note cards. And the benefit of note cards is you can lay them out in front of you. You write only on the front side. You don't write on the back side, because that entails you having to flip over and remember to flip over to look for certain things. You only write on the front sides, okay? So if you choose to do note cards, then write only on the front side and never on the back. So when you lay them out in front of you, you see it all in one glance. That's the idea. Now, some of you are more tech savvy and you would prefer to create something called an electronic notebook. It's basically, we would take, I would create a file for you. I've already done it, and I send it to you, and you fill in. You would do the name of the postulate, which we would number it. You would identify it, which means you would tell what that postulate says, and then you just would fill in a template, and it would be there, and you may even be able to draw an example or find an example online, to demonstrate that for you in a picture, okay? The beautiful thing about note cards is the worst thing that can happen is you lose your note card, you redo it, you can hand draw it in your own handwriting, you can color code. A little bit more limitation with electronic notebook. It's not as bulky. If you get a bunch of note cards, you could lose them and not keep up with them and have so many that you get overwhelmed. The electronic notebook, it's all in one place. You can pull it up. Cons would be you lose the file, something happens to it, you aren't able to find it on your computer or whatever. So the idea is this year we're going to have access to these Chromebooks, and although each of you aren't going to have your own as of this point in time, maybe in the future, we will have access to it, and it's something I'd like to incorporate into our class a lot, is using those Chromebooks. So it may be a good idea to have an electronic notebook file we do in class, and then you can have note cards at home. I don't know. I'm just throwing out ideas because I don't know what's best for you. I just really want you to choose that. Now, the postulates that you need to put on your note cards, here they are. The first number is the chapter that we're in. So we're in chapter 1, obviously. The second number is what section are we in. We're in section 1. And the third number just distinguishes and differentiates. So if you're in the same chapter and section, then you do need to, and you have more than one postulate, then you need to distinguish between them. So we're in Chapter 1, Section 1, and this is the very first postulate. So 1-1-1 is Chapter 1, Section 1, first postulate, okay, in this particular grouping. And it says, through any 2 points, there is exactly one line, okay? So when you are asked to identify a line, let's say, because that's what they're going to do in our example, identify a line, you are going to use this postulate. You are looking for 2 points. Let's underline that, 2 points. That's what you're looking for, any 2 points. And if you see a line running through any 2 points, then we can name that line. We can name it using the lowercase italicized letter, or we can name it using 2 points that are identified on that line, okay? Now, the second one, 1-1-2. This is Chapter 1, Section 1 again, but this is the second postulate, so that's where the 2 came from. Through any 3 non-collinear points, that means they're not on the same line, there is exactly one plane containing them, okay? So any 3 non-collinear points, we have a plane, okay? Any 2 points, we have a line. These are, see how basic it is? You're probably going, why are we learning this? Well, these are postulates. We can't prove them, but these are accepted as being true, okay? And then the last one, 1-1-3. If you have 2 points that lie in a plane, then the line containing those points lies in the plane, okay? So let's see if we can make sense of this. You have 2 points in a plane, then that line that contains those points also lies in the plane. Okay, so again, electronic notebook, this would be a good time. Use your template or create note cards, however you want to do that. And you know, we will have already had a couple days of class, I think. By the time we get here, you probably will already have your template. All right, let's flip the page. Example 3, they've given us a figure, as you can see to the right. Name a line that passes through 2 points. Okay, that's postulate 1-1-1. Any 2 points that connects, a line is going to run through them, and that's what we're looking for. So here, right there, circle it if you want to. Do you see the points G and H? There's a line. We know it's a line because we see arrows at each end. And so to name this line, we can do it one of 2 ways. We can use the little lowercase letter and go, okay, that's line N. Or, even better, you can use your symbols that we've learned. You can do your letters, I don't care if it's GH or HG, and then put a double arrow on top of that, a line with double arrows there, okay? So either way is fine. There, you've named your line. That's line N or it's line GH. If you do the 2 letters, you don't have to write the word line. You could just use the symbol, okay? Name a plane that contains 3 non-collinear points. Well, as you can see, G, H, and F, okay? So you can call this plane and use your 3 letters, G, H, F. Okay, it doesn't matter what order they're in, just make sure you have the 3 letters there. Or you could use, remember this? That's that capital script letter. And you can go, oh, that's plain, and then do your best to write that letter out. Plain R, there's my script. That's just gorgeous, isn't it? Okay, so there you go. Got you guys started on your electronic notebook if you want to do that, or your note cards, or both if you would like to benefit from both of those, okay? So thank you for listening. Jot down any questions you have about those postulates, and take the extra few minutes and get that electronic notebook filled in on those postulates. All right, see you tomorrow.